Hello guys, in our journey of IIT JEE Mains Advanced, the first chapter we have is the foundation. Basically not a chapter, but just the foundation. So this is not a chapter, we'll discuss some concepts which will be used throughout. And first topic in that is Wavy curve method. Wavy curve method will be used to solve inequalities. Like they will say x minus 1, x minus 4 is greater than 0. For what values of x it will be true. So these kind of inequalities, how to solve, we'll discuss in Wavy curve method. So this is very important. So let us see this thing. So we start from the basics. Whoever has done till 10th grade, they can start here. Nothing else is required to study this thing. So this is the first topic we can see when we start your journey of IIT JEE Mains Advanced. First we have here number line. What is the number line? A horizontal line will draw. Line is infinite. It will be like this side will be going infinite. And we'll plot some number on that. In the middle we put 0, 1, 2, 3 and so on. Minus 1, minus 2, minus 3, minus 4 and so on. And do remember when we say numbers, it is not only the integers. It will be the other numbers also, all real numbers. So it could be 0.5 also. It could be 0.7 also. Everything will be there in the number line. And if I say to mark the intervals x greater than equal to minus 1 and less than equal to 1, that means the interval from minus 1 to 1, which I have shaded here with the pink line. So this is number line. We'll be using it while solving the problems. Next we need to understand what are intervals. How do we write the intervals? See, x greater than equal to 1 less than equal to 4 means x can lie anything from 1 to 4. Again, when I say 1 to 4, it could be any real number. It could be 1.2, 2.7, anything, not only the integers. Now, how do we write this thing? We can write this thing as x belongs to 1 to 4. This symbol here, which looks like E, we read it as belongs to. This is close interval 1, comma 4 close interval. So starting value 1, final value 4, close interval. This is a close interval, and we'll have open interval also. We'll see with the help of next example what is the difference between them. See, in the first problem, x is greater than equal to 1 and less than equal to 4. In second, x greater than 1 less than 4. So what is the difference between first and second? In first, we can take 1 also, 4 also. In second, we cannot take 1 and 4. Then x should lie strictly between 1 and 4. So to differentiate between these two, we have different brackets. So when you want to include a number, we use close bracket like we have here. And if you do not want to include a number, we use open bracket like we have here. So close bracket means the number is included, open means the number is not included. See, third example, x is greater than 1 less than equal to 4. So here 1 to 4, 1 will be open, 4 will be closed. Next, x greater than equal to 2. What do we have here? Starting value is 2, but when we say x greater than equal to 2, that means there is no ending value. So how do we represent that? We use this infinity. I hope most of you will have the idea what is infinity. So basically it's like never ending. To express that in the form of mathematics, we use this symbol and we call it as infinity. So we read as 2 to infinity. 2 will be close bracket and infinity will always be open bracket. We'll never close infinity because infinity is not a number. It is just expression that it is never ending. Next, if we have something like x greater than equal to 1 or x less than equal to minus 1. So x greater than equal to 1 means 1 to infinity. X less than equal to minus 1 means minus infinity to minus 1. Okay, for the left side of the number line, when we say something is less than minus 1, so what is the least value? There is no least value. It could be anything in the negative. So we say minus infinity. That means never ending on the negative side. So again, infinity will always be open. So open minus infinity to close minus 1 and 1 to infinity, close 1 to open infinity. Now the or. How do we represent or in mathematics? We use this symbol capital U and we read it as union. This thing we read as union. So we'll say x belongs to minus infinity to minus 1 union 1 to infinity. Next one, x greater than equal to 2 and less than equal to 4. So we just see, if I say x is greater than equal to 2 and less than equal to 4, and means it should satisfy both of them. So what numbers we can take? We can take numbers only between 2 and 4, and we can include 2 and 4 also. So close 2 to close 4. I hope it makes sense. Let us go to the next thing now. So this is how where we start. How do we solve the question on this thing? First one, we have f of x equal to x minus 1 into x minus 3. Now what is this f of x and all? See, this is an expression. We just write it as f of x. Okay, so we're giving a name to this thing. And what is f of x here? Basically, we say this is a function of x. Now, this function of x and all we'll discuss in detail later. Just right now, you see, this is kind of a name given to this thing. That's all. If I say f of x in this problem, it means this thing. And what is the significance of x here? So if I say f of 4, you will put x as 4. So you get 4 minus 1, 4 minus 3. So you get 3 into 1, that will be 1, 3. Okay, into basically we use for multiplication. It's not 3.1. 3 into 1, that is 3. Now, how do we solve the problems here? It's this saying solve fx greater than 0, fx less than equal to 0. Solve basically means here you have to find the values of x for which these inequalities are true. Fx greater than 0, fx less than equal to 0. Like there are two different parts. So we have to find the values of x for which this is true in the first part and the values of x for which this is true. How do we do this thing? See, first of all, you have to find the roots of the equation. Roots basically are the values of x for which this expression would be equal to 0. And by now you have done the quadratic equations and all. So you know what are roots here. So we can see that this thing will be 0 when x is 1. This thing will be 0 when x is 3. So roots are 1 and 3. Now you will plot the roots on the number line. We discuss number line. So 1, 3. Now, what are the signs that I have marked here? See, these roots will break this whole number line into three parts. One is those numbers which are more than 3. One is those numbers which are between 1 and 3. One is those numbers which are less than 1. Now we need to see how the function behaves there, how the value of fx behaves there. In the first part, we'll see if it is positive or negative. In the second part, we'll see if it is positive or negative. In the third part, we'll see if it is positive or negative. Now, how do we check that? Right now, just let us see with the help of example. Take any number which is more than 3. Let us just say 4. If I put 4 here, you'll see this will be positive, this will be positive, product will be positive, so you get positive. Next, take some number between 1 and 3. Let us say 2. Put it here. You will see this will be positive, but this will be negative. And when you multiply positive and negative, we get negative. Next, take some number less than 1, let us say 0. Put here, you get negative, negative, and you multiply, you get positive. So before 1 it is positive. So what do you get? Positive, negative, positive. Now, in this problem we have checked, but next time you don't need to check also. After you plot the roots on the number line, start from the right side. Rightmost point will be positive, rightmost part will be positive, and then after that just alternate signs, no matter how many parts are there. So here positive, negative, positive, and if there were more, you just keep on alternate. Now, first they're asking the values of x for which fx is greater than 0, means positive. So where do you see it is positive? It is positive when x is less than 1 or more than 3. Next, fx less than equal to 0 means negative or 0. Where it is negative? Between 1 and 3. Where it is 0? At 1 and 3. So the final answer will look like this. For greater than 0 will be minus infinity open to open 1 union open 3 to open infinity. For fx less than equal to 0, it will be x belongs to close 1 to close 3. I hope it is clear to all of you. If it is not, you can just like rewind and see this thing again. If it is clear, then let us go to the next one. So this next problem, I'll just show you, and you can just stop it here and try this problem once yourself, and then we'll discuss. Okay, guys. Now we'll discuss this problem. So see, in the next one, they're saying f of x is x minus 1, x minus 3, x minus 5, and we can see the roots are 1, 3, 5. Plot the roots here, 1, 3, 5. Like we discussed, rightmost is positive, then negative, positive, negative. First case, you want fx to be greater than 0. Where it is greater than 0? Between 1 and 3 and more than 5. Fx less than equal to 0. Where is less than equal to 0? Before 1 and between 3 and 5. Fx equal to 0. Where is fx equal to 0? At 1, 3 and 5. So the answers will be these. You can match your answers. Greater than 0. X belongs to open 1 to open 3 union open 5 to infinity. Less than equal to 0. X belongs to open minus infinity to close 1 union close 3 to close 5. Fx equal to 0. X is equal to 135. I hope it is clear. Let us go to the next problem. I just want to take a pause and try this problem once yourself, then we'll start discussion. Okay, guys, we'll start discussion now. So what are the roots here? You can see roots are minus 2, minus 1, 1 and 2. Again positive, negative, positive, negative, positive. What do you want? Fx less than 0. So less than 0 between minus 2, minus 1, 1 to 2. All will be open because we cannot have 0. You want strictly less than 0. So less than 0 will be between them. So answer will be minus 2 to minus 1 union 1 to 2. All the brackets are open. I hope it is clear. Let us go to the next problem. Okay, now you all can take a pause and try this problem once yourself. Okay, we'll discuss now. See, f of x is equal to x minus 1, x minus 3, x minus 5 by x minus 2, x minus 4. Whenever you have something in the denominator, just remember denominator should never be 0 because something by 0 is not defined. In the starting only we can define that x cannot be 2 and 4. Now, then what about the roots, the number line? So I just change the terminology here. till now I was using the term roots, but I'll not use the term roots right now because that will not be correct. I'll use the term critical points. Okay, just like to explain, I'm using the term critical point. Now, what I'll refer to as critical point, it will be that value of x for which a particular bracket will be 0. Like in this case, this bracket will be 0 when x is 1. This is 0 when x is 3. This is 0 when x is 5. This is 0 when x is 2. This is 0 when x is 4. So all these are critical points are there, and we'll plot all of them on number line. Yes, we'll plot all of them on number line, not only the roots. Roots are basically those values for which numerator is 0. But even the denominator ones will take. We can't take exactly 2 and 4, but they will make the sign changes. So we'll plot all of them on number line. So how will that look like now? This 1, 2, 3, 4, 5, again positive, negative, positive, negative, positive, negative. Alternate signs starting from rightmost positive. You want f of x to be greater than equal to 0. Where do you see fx is great positive first? 1 and 2, 3 and 4, more than 5. So first just write 1 and 2, 3 and 4, 5 to infinity. Now we'll see the brackets. They want fx to be greater than equal to 0. That means the numerator can be 0. That means 1, 3, 5 we can take close. 1, 3, 5 we can take close because if I put x as 1, 3 or 5, fx will be 0. But 2 and 4 has to be open only because denominator cannot be 0. Keep this thing in your mind. Denominator cannot be 0. I hope it is clear. Next problem. See, this is the next problem. You all can take a pause and give it a try. Then we'll start discussion. Let us start now. See, f of x equal to x minus 1, x minus 2 whole square, x minus 3 whole cube. Now, what do we do here? Keep one thing in your mind. The roots basically here are 1, 2, 3 only. But the roots are raised to some power now. It's x minus 1 power 1 only, but x minus 2 power 2, x minus 3 power 3. What rule you have to remember here? The root having even power not to be plotted on number line for signs. The root which has even power will not be plotted on number line for signs. Why? Because see, x minus 2 square is there. If I put x more than 2, it will be positive. If I put x less than 2, it will be positive. That means this does not make any sign changes. X minus 2 square will always be positive only. So this we can neglect for sign changes. So what we'll have is 1, 3. Positive, negative, positive. But at 2, value will be 0. This right now says that between 1 and 3 value is negative, but that is not true. At 2 value is 0. So just to remind ourselves, we put it here separately. So we say between 1 and 3 value is negative, but at 2 value is 0, just to remind ourselves. Now, fx less than 0. So for what values of x, fx is less than 0, you can see negative between 1 and 3. So we say x belongs to 1 to 2, union 2 to 3. Why? Because at 2 it is not negative. So we can write like 1 to 2, union 2 to 3. All open brackets because you want strictly less than 0. This thing we can write in this way also. X belongs to 1 to 3. X belongs to 1 to 3. But we have to exclude 2. Now how do we exclude a single number out? We say minus. Minus is for exclusion. 2 we write inside curly braces. What are these curly braces for? This will represent a set. What is this and all? We'll discuss in a separate chapter, sets. So for now, just remember this thing only. If you want to exclude some element, you write it as a set. And how do you write a set? With the help of curly braces. So we say 1, 2, 3 minus 2. Okay, next. Fx greater than 0. Where do you see fx greater than 0? Before 1 or after 3? So x belongs to minus infinity to 1 union 3 to infinity. Last, f of x greater than equal to 0. Where do you see f greater than equal to 0? We see before 1, after 3, or at 2 also, no? Because you can have equal to 0. So now we'll say minus infinity to 1 closed, union 3 to infinity, 3 closed. Now we have to add a single element. And how do we add a single element? We use the symbol union. Okay, we don't use plus. For exclusion we use minus, but for inclusion we use union. But we have to add a single element too. So we'll write it inside curly braces. I hope it makes sense. If it not, just rewind it and then go to the next problem. Okay guys, this is the sixth problem. F of x equal to x minus 1 into 3 minus x. You want fx greater than 0. Give it a try. Then we'll start discussion. Let us start. Now, see guys, now there's one interesting thing here which we have not seen till now. Till now, everywhere we have x minus something, x plus something and all. But this problem we have x minus 1 into 3 minus x. Just keep one thing in your mind. Whenever using the wavy curve method, x thing has to be positive. So this 3 minus x, I have to make x minus 3. So I'll take negative outside. Now, if I be using wavy curve on x minus 1, x minus 3, with this thing 1 and 3 are the roots, positive, negative, positive. But if we have a negative outside, it will reverse everything. So whenever it was positive, it will make it negative. And when this thing was negative, it will make it positive. So now we get negative, positive, negative. So basically, if you have a negative outside, we can do, after you find wavy curve thing, just inverse all the sign. So plus make minus, minus become plus. So we get this our wavy curve here, and they want fx to be greater than 0. We can do between 1 and 3. So it'll be open 1 to open 3. So keep one thing in mind, x has to be always positive. So if it is not positive, we make it positive by taking negative outside. Next, we can do one more thing here also. After we get this thing, rather than changing the wavy curve, we could have done this thing. I'll just make some changes here. They're asking us to solve fx greater than 0. Now what is fx? It is minus of x minus 1, x minus 3. You want greater than 0. What you can take is multiply minus 1 both sides. And when you multiply minus 1 both sides, the inequality will change. So get x minus 1, x minus 3 less than 0. And now we can use wavy curve on this thing, x minus 1, x minus 3 only. So now we want it to be negative. Negative is between 1 and 3, so answer will be x belongs to open 1 to open 3. So the same thing. This will be easier for you to understand. Next problem. So fx is x minus 1, x minus 2, 3 minus x. They want you to solve for fx greater than 0. You can give it a try, then we'll start discussion. Let us start discussion now. So again, you can see the roots are 1, 2, 3, but there is 3 minus x. So rather than doing this thing, I'll just change like we discussed in the previous problem. I'll make it that we'll take negative outside, we'll get minus of, so basically I'll take negative outside, this 3 minus x will become x minus 3, and negative will be outside, that will multiply both sides, so it will become x minus 1, x minus 2, x minus 3 less than 0. It's like in the previous one I have done here. This negative I'll take outside, then multiply minus 1 both sides, so it will become less than 0, and Wavy curve we use on our normal thing only. So we use Wavy curve on this thing only. Just rightmost corner positive, negative, positive, negative. We want less than 0, so answer will be here. Minus infinity to 1, union 3 to infinity. I hope it is clear. Next problem. 8th one. F of x equal to x minus 1 into x minus 2 power 4 into x minus 3 power 5 into x minus 4 power 6 into x minus 5 power 7. Solve fx less than equal to 0. You all can try this problem. Okay, let's start discussion now. So what do you see now? The roots are 1, 2, 3, 4, 5. But like we discussed, the even roots will not plot. So we'll plot only 1, 3 and 5. So 1, 3, 5, positive, negative, positive, negative. But just to remind ourselves that value at 2 and 4 is 0. So we'll put them separately. They want fx to be less than equal to 0 means negative or 0. So where do you see negative? Before 1, between 3 and 5. So before 1, we have x belongs to minus infinity to 1 closed. I closed because you want equal to 0 also. Union 3 closed to 5 closed. Union the roots which we have taken separately. Plus 2 and 4. You see 4 is already there between 3 and 5. But 2 is not there right now, so we have to include 2 separately. So union 2. Value at 2 is also 0, and 2 does not come here right now. 4 comes between 3 and 5, but 2 doesn't. So we include 2 separately. So this is your final answer. I hope it is clear. Let us go to the next problem. Okay, now some random problems are there. 2x minus 3 over 3x minus 5 greater than equal to 3. Solve for x. You can give it a try, then we'll start discussion. Let us start discussion now. See, whenever you have this kind of problem, just keep one thing in your mind. Cross multiply only if number in the denominator, I have used some short form here, if number in denominator is positive. If it is negative, then inequality will change. See, if I say 1 over 3 is more than minus 1, it is true. If you cross multiply, it will still be true. But if I say let's say if I say 1 over minus 2 is greater than minus 4, this is true right now. But if I cross multiply, it will become 1 greater than 8, which will not be true. So if you cross multiply a number which is positive, inequality is same. If it is negative, it will change. But in the denominator, we have 3x minus 5. Now 3x minus 5, we don't know if it is positive or negative. That will vary with the value of x. So when this kind of thing is there, which is varying its sign, remember in your mind, do not cross multiply. So if we do not cross multiply, how else do we solve? We take this 3 on the left side, so you get 2x minus 3 over 3x minus 5 minus 3 greater than equal to 0. Now just take LCM and solve. So what you will get here, you get 2x minus 3 minus 3 times 3x minus 5 over 3x minus 5 Upon simplification, you get minus 7x plus 12 over 3x minus 5. Again, you have to use the Wavy curve method where the x value is negative here, no, by minus 7. So we take negative outside and take to other side, you get 7x minus 12 over 3x minus 5 is less than equal to 0. Now, the roots are 5 by 3 and 12 over 7. When you're plotting the number line, you see the smaller root we keep on left side, the greater we keep on right side. But which of them is greater? The number are too close. We cannot see which of them is greater directly. What we do is just cross multiply. This side I get 35, this side I get 36. That means the right side is greater. That means initially 12 by 7 was greater. So 12 by 7 is more, 5 by 3 is lesser, positive, negative, positive. But we want less than equal to 0, that is negative. So between 5 by 3 and 12 by 7, we can have equal to 0 also. So the numerator root will be closed, but denominator one will be open because denominator can never be 0. I hope it is clear. Next. Now, just a simple problem. Solve x for which 2x minus 3 lie between minus 5 and 7. All of you can try it. Okay, let's start discussion now. See what we do here step by step. We don't need to solve this separately and this separately. I'll give you a method we can solve both of them at the same time. Left and right both inequality at the same time. See 2x minus 3. What you do is add 3 to all the terms. So this will become minus 2, this will become 2x, this will become 10. Now divide to all the terms. Get minus 1, x 5. So answer is just x belongs to minus 1 to 5. That's all. I hope it is clear, guys. So this is first part of the Wavy curve. We'll continue in the next class. Bye.